Burn permafrost peatlands release carbon for years after wildfires, according to a new study at the University of Alberta. Peatlands are a type of wetland whose soils consist of waterlogged organic matter from decaying plants, forming layers of partially decomposed peat. They cover about 3% of the world's land area, yet store twice as much carbon as all the world's forests combined, meaning their conservation is important in the fight against climate change. But Canada's peatlands are burning, releasing the stored carbon and accelerating global warming. The question is, by how much? Led by lead author and newly granted PhD Christopher Schulze, the study found that after permafrost peatlands burn, they can release large amounts of long stored carbon for several years. This means that as the hot climate heats up, and the frequency and severity of wildfires in Canada's northwest boreal peatlands increases, these peatlands could turn from carbon sinks, absorbing greenhouse gases, into carbon sources. The researchers examined carbon exchange, the process of releasing carbon into the air versus absorbing it back into the ground in Canada's taiga plains. They measured carbon exchange in the first 4 years after two peatlands burned in 2007 and 2019, and determined how long it took for them to recover to a carbon sink. They found burned peatlands experienced large carbon losses for several years after the fire, losing 130 grams of carbon per square meter because of fire-exposed peat and lesser uptake of CO2 by burned vegetation. The combined combustion of 15 years of carbon release resulted in a total loss of 2.9 kilograms of carbon per square meter, with post-fire emissions at 40% of that amount. This study suggests that the extreme wildfires in 2023 that burned 15,000 square kilometers of peatland released about 2 million tons of carbon dioxide in 2026, equivalent to the emissions of 500,000 Canadians. They also found that after 155 years, burned peatlands regained their carbon sink status, but frequent burning due to climate change could inhibit that. What's so important about this research is that for the first time, the results were measured over multiple years, which will aid in creating a more accurate climate model and peatland conservation. Do you think we should account for long-term emissions in climate models or stick with the annual ones?